A point object is placed at a distance of 12 centimeter on the axis of a convex lens of focal length 10 centimeter. On the other side of the lens, a convex mirror is placed at a distance of 10 centimeter from the lens such that the image formed by the combination coincides with the object itself. What is the focal length of the convex mirror? Options: 10 centimeter, 15 centimeter, 20 centimeter and 25 centimeter. Dear students, let us take the help of ray diagram to solve this problem, since it is a combination of a convex lens with a convex mirror. So, if this is convex lens and here it is convex mirror, they are placed coaxially, and from the lens at a distance of 12 centimeter an object is placed. This is 12 centimeter and the distance between the lens and the mirror is also given to be 10 centimeter. Okay. Now, what is the condition? The incident rays which start from object, they move towards the lens and they get converged by the convex lens and they get converged at a point so as to produce an image somewhere. In the absence of this mirror, these two rays would have converged somewhere here to produce an image whose distance is v, which can be calculated easily using this object distance and the focal length of the lens by using lens formula. But the idea is different here. You are not allowed to produce an image on this side of the lens. What is the condition here? The image should coincide with the object itself. So, what does that mean? After refraction through this lens, reflection should take place, as a result of which these rays should come back. Once again they undergo refraction to produce an image here itself on O. This will happen only when these rays, after refraction and after striking this mirror, these rays should retrace their path. That is the only condition when the image will coincide with this object. I repeat, after refraction, these refracted rays, after reflection, they should retrace back. And when do you see the reflected rays retracing their path? This will happen only when you incident normally on a mirror, whether it is a plane mirror or a curved mirror, the rays will retrace only when you incident normally. So, these rays should be incident normally on this mirror. What do you understand by this word? If they are incident normally, if you produce them, this should meet at center of curvature. So, what does that indicate? In the absence of this mirror, the convex lens alone should have produced the image at this point. This point is nothing but the center of curvature of this convex mirror. So, what happens due to the presence of this mirror? These rays are incident normally and they get retraced back. They get converged at point O, producing an image at the same point. So, what is that data we obtained from this idea? The image produced by this lens, which is at a distance v, in the absence of this mirror, is at point C. So, what is the distance between mirror and C? This is radius of curvature r. Now, can I calculate this v using u and focal length? U is minus 12 centimeter and focal length is positive. It is given to be 10 centimeter positive. So, I will take mirror formula, 1 by V minus 1 by U is equal to 1 by F. I want 1 by V. 1 by V is equal to 1 by F plus 1 by U. So, which is 1 over 10 minus 1 by 12. So, this is 60 is LCM. This is 6 minus 5 is 1 over 60. That gives me image distance is 60 centimeter. This is the distance from lens to the point C, and this is 10, this is R. So, what does that mean? 10 plus R is 60. So, this is 60 centimeter is nothing but 10 plus R. So, this gives me R as 50 centimeter. What does that mean? I got the radius of curvature of this convex mirror. And how do you calculate focal length? They are related. F is equal to R by 2. Half of radius of curvature is your focal length. Half of 50 is 25. So, focal length is r by 2, which is 25 centimeter. Option D is right answer. Let us go to the next problem. A plano-convex lens of refractive index 1.5 and radius of curvature 30 centimeter is silvered at the curved surface. This lens is used to form the image of an object. At what distance from this lens an object be placed in order to have a real image of the size of the object? Options: 80 centimeter, 60 centimeter, 30 centimeter and 20 centimeter. Dear students, let us take plano-convex lens first, which is silvered at its curved surface. Okay, this is silvered at its curved surface, principal axis. Then how does it behave? A plano-convex lens, when silvered at the curved surface, it behaves as a concave mirror. Look at this. Since this surface, concave surface is reflecting surface, this acts as a concave mirror. Now, you place object here, you get the image, you will get the real image. But the idea is, there is a condition for the image, the size of the image should be same as that of the object. So, does a concave mirror give you the image whose size is same as that of the object? Yes, it does. When the object is placed at 2f, then size of the image is same as that of the object. That is, when object distance is 2f, image distance is also 2f, real image, inverted image, their sizes are same. So, what is the solution here? Find out the focal length of this and place the object at 2f, that gives you the required answer. So, your required answer is 2f. So, how do I find out focal length of this combination? The idea is, when you place an object over here, the rays start to pass through the lens first, undergoes refraction through lens and gets reflected by the mirror, since this surface acts as a mirror, and again it undergoes refraction through the lens once again and finally comes out. So, for any incident ray, there are two lenses and one mirror. I repeat, any incident ray will undergo twice refraction and once reflection, which means the ray passes as if there are two lenses and one mirror. So, this is a combination of lenses and mirror. So, find the effective focal length of this combination. How do I find? Using the effective focal length formula for combination of lenses, which is given by 1 over f, which is the effective or equivalent focal length. It is given by, so since there are two lenses, I should write 2 by f. It is nothing but 1 by f plus 1 by f. Remember, this f is for the lens and there is a mirror also. So, write 1 by fm. Fm is the focal length of the mirror. Now, how do I find out fl and fm? If you can find out, substitute, that is the end of the answer. To find fl, they have given me refractive index and radius of curvature. Obviously, I will have to make use of lens maker's formula. 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. Then, how do I find out fm? Yeah, its radius of curvature is known, half of which will give you the focal length. That is it. So, let me find out fl first using lens maker's formula. So, for lens 1 by fl is equal to n minus 1. I do not think I need to write the formula, let me substitute directly. N minus 1 is 1.5 minus 1 into 1 by r1 minus 1 by r2. What is r1? For plane surface, radius is infinity. For r1 is infinity. What about r2? For the curved surface, r2 is given to be 30 centimeter and it has to be negative, because this is incident ray direction and your measuring is in the opposite direction. Therefore, 1 by r1, 1 by infinity minus, this is minus 30 centimeter. So, 1 by minus 30. So, this is 0.5 divided by 30. This is 1 by 60. 1 by 60 is my FL, so that gets me FL is equal to 60 centimeter. Now, I got this value. What about FM? Half of radius of curvature. So, radius of curvature, okay, FM is R by 2. Its radius is 30 divided by 2 and 30 has to be negative again. This is minus 30 by 2 gives me minus 15 centimeter. Substitute these two values here. 1 over F is equal to 2 by FL is 60 minus 1 by 15. So, 60 is LCM, 2 minus 4 is minus 2 by 60 is minus 1 by 30. So, which means the focal length, effective focal length of the combination is minus 30 centimeter. Minus 30 centimeter. It is negative because it acts as a concave mirror. Next idea, where are you supposed to place the object at 2F to get the image whose size is same as that of the object. So, object should be kept at 2F, which is minus 60 centimeter. Do you have an option? Yes, option B is correct. Look at the next question. The size of the image of an object which is at infinity as formed by a convex lens of focal length 30 centimeter is 2 centimeter. If a concave lens of focal length 20 centimeter is placed between the convex lens and the image at a distance of 26 centimeter from the convex lens, find the new size of the image. Options: A 1.25 centimeter, B 2.5 centimeter, C 1.05 centimeter and D 2 centimeter. The students, it's a lengthy problem where there are a number of data given. Seems to be a complicated problem, but it is not a complicated one. Here, let me make it simpler by the help of a diagram. Let me take the convex lens first. Okay, this is the convex lens whose focal length is 30 centimeter. The focal length of this lens is 30 centimeter. Now, where is the object kept? Object is at infinity. Okay, we can expect parallel beam of light to be incident on the convex lens because object is at infinity. Okay, these parallel rays strike this lens. Next, obviously, the image should be formed at focus of this lens. And we know that the focal length is 30 centimeter, so image should be at a distance of 30 centimeter from this lens. Okay, let me write that image, and the nature of the image should be real and inverted for a convex lens. And one more important thing is its size is given, the size of this image is given to be 2 centimeter. Let me write it. So, this is the image of size 2 centimeter. Now, one more hurdle for this image is there is a concave lens kept between this convex lens and this image. Okay, place a concave lens now, where at a distance of 26 centimeter from the convex lens. I repeat, concave lens has to be kept at a distance of 26 centimeter from this convex lens. So, this distance is 30 centimeter. Now, place a concave lens. Okay, now this distance is 26 centimeter. So, obviously, this has to be 4 centimeter from image to the lens. Now, what is the question asked? If this is the image produced by the convex lens alone, now due to the position of this concave lens, what is the new size of the image? Now, we will have to think about the image produced by this concave lens now. So, image produced by convex lens acts as virtual object for this concave lens. This is the idea here. I repeat, for this concave lens, this acts as object which is virtual. Now, object distance is known, which is 4 centimeter. Focal length is known, 20 centimeter, obviously negative. So, find out image distance. You can find out image distance, but that is not the question. Question is, what is the size of the image produced by this lens? Size of the image can be found out if the magnification is known. So, what are we supposed to find out is the magnification of this concave lens. So, magnification of a lens can be expressed in terms of focal length, which is, I will write the formula for magnification. Remember, I am writing this for the concave lens because the ideas of convex lens is very clear. Object at infinity, image is at focus, which is at a distance 30 centimeter, clear, and the size of the image is 2 centimeter. Now, I am writing for concave lens. For concave lens, where is the object? Distance of 4 centimeter. What is the sign? It is positive because this is the incident ray direction and you are measuring the object distance along the same direction. So, for concave lens, object distance is 4 centimeter, focal length is negative minus 20 centimeter. I am not supposed to find out the image position, instead I want the size of the image. So, for that let me calculate its magnification. Magnification can be expressed in terms of f and u. So, it is given by f divided by f plus u for lenses. Now, substitute minus 20 divided by minus 20 plus 4 is minus 20 divided by minus 16, magnification is 5 by 4. Magnification is 1.25. Now, what is the size of the image and size of the object? Magnification can be expressed in terms of height of image divided by height of object. I want height of image, which is magnification times height of object. Height of object is 2 centimeter, magnification is 1.25. So, this gives me height of image is equal to 1.25 into height of object is 2, which is 2.5 centimeter. But I think there is a shortcut for this. You can work it out in a much simpler way. You need not do so much of calculations. Look at the shortcut. In the absence of this concave lens, the image would have formed over here, whose size is 2 centimeter. But what is the function of this concave lens? It diverges. The incident ray or incident beam is diverged. And what does that result in? It makes the image to be produced away from the lens. So, concave lens does not allow the image to be formed here. So, it just pushes the image away. So, what does that mean? For concave lens, this is object distance and image is farther than object. That is the clear idea. Image should be farther than object. So, what does that make? Magnification formula. Take the magnification formula. M is V by U. If V is greater, as in this case, if V is greater, M is greater than 1. What does that mean? Size of the image should be greater than that of the object. So, what is size of the object? 2 centimeter. So, image size should be greater than 2 centimeter. Look at the options. There is only one option which is greater than 2 centimeter. It has to be the correct answer. Now, let us take up a problem on eye defects, dear students. It goes like this. A person with defective eyesight is unable to see objects clearly nearer than 1.5 meter. He wants to read a book placed at a distance of 30 centimeter from his eyes. Find the power of the lens he requires for his spectacles. Options: plus 2.67 diopter, minus 2.67 diopter, plus 2.5 diopter and minus 2.5 diopter. The idea is he cannot see the objects which are nearer than 1.5 meter. What does that mean? A normal human eye, for normal human eye, the near point should be around 25 centimeter. But for this defective person, near point is shifted to 1.5 meter. So, it is a clear case of hypermetropia. for which the solution or the remedy is convex lens. What does that mean? The power of the lens should be positive. You can directly eliminate two options, option B and D. So, which is the correct out of A and C. To find the power of the lens, you will have to make use of the lens formula and find the focal length of the required lens, thus find out the power of the lens. See, the aim of the person is to read a book which is at a distance of 30 centimeter from him. So, object distance is mentioned, it is 30 centimeter. So, object distance is 30 centimeter, obviously it is negative, minus 30 centimeter, and I want its image to be formed at a distance of 1.5 meter, that is 150 centimeter, because when the image is formed at 1.5 meter due to the spectacle, then his eye lens will produce the image wherever required. So, the duty of the lens is to produce an image at 1.5 meter when the object is kept at 30 centimeter, that is it. So, object distance is known, image distance is known, find out its focal length and thus its power. So, its image distance is 150 centimeter, it is also negative. How to find focal length? Lens formula 1 by f is equal to 1 by v minus 1 by u. Directly I can find out f, which is uv divided by u minus v, which is minus 30 into minus 150 divided by minus 30 plus 150, which is minus 30 into 150 minus 150 divided by 120. 4 times 150 by 4 is 75 by 2, which is 37.5. So, f is 37.5 centimeter positive and power is asked. So, P is equal to, it has to be in meter, 1 over 0.375. So, if it is 0.4, you would have got 2.5, slightly less than 0.4, it should be greater than 2.5. So, greater than 2.5 should be 2.67 with a positive sign. Option A is correct, that is power has to be 2.67 diopter positive. I would like to continue with this. If the problem was myopia, that is the short sightedness, then the far point of the person would have been shifted from infinity to some other point. Say for example, if the far point of a person is 2 meter, then straight away the spectacle, the nature of the spectacle the person should be using should be of negative power, which is concave lens, and its focal length is straight away minus 2 meter. I repeat, if the far point of a person is some x meter say, then the focal length of the spectacle the person should be using is equal to minus x meter, reciprocal of which will give you the power. But when hypermetropia case is given like this, then the power can be calculated using the formula, lens formula. ಪ್ರಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಇಷ್ಟೊತ್ತು ನಾವು ರೇ ಆಪ್ಟಿಕ್ಸ್ ಆ್ಯಂಡ್ ಆಪ್ಟಿಕಲ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಅಧ್ಯಾಯದ ಅನೇಕ ವಿಚಾರಗಳನ್ನು ಮತ್ತು ಪ್ರಶ್ನೋತ್ತರಗಳನ್ನು ಅಭ್ಯಾಸ ಮಾಡಿದ್ವಿ. ಈ ವಿಚಾರಗಳು ಮತ್ತು ಅಭ್ಯಾಸ ಮಾಡಿದಂತಹ ಪ್ರಶ್ನೋತ್ತರಗಳು ಮುಂಬರುವ ಪರೀಕ್ಷೆಗಳಲ್ಲಿ ನಿಮಗೆ ಸಹಕಾರಿ ಆಗಲಿದೆ ಅಂತ ನಾನಾದರೂ ಭಾವಿಸ್ತೀನಿ. ಸತತ ಪರಿಶ್ರಮದಿಂದ ಇನ್ನೂ ಹೆಚ್ಚಿನ ಪ್ರಶ್ನೋತ್ತರಗಳನ್ನು, ಲೆಕ್ಕಗಳನ್ನು ನೀವು ಅಭ್ಯಾಸ ಮಾಡಿದ್ದೇ ಆದರೆ ಅಭೂತಪೂರ್ವವಾದ ಯಶಸ್ಸು ನಿಮಗೆ ಮುಂಬರುವ CET ಅಂತಹ ಪರೀಕ್ಷೆಗಳಲ್ಲಿ ಲಭಿಸಲಿದೆ ಅಂತ ಭಾವಿಸುತ್ತಾ ಇಷ್ಟು ಹೊತ್ತು ನಿಮ್ಮೊಂದಿಗೆ ಇದ್ದಿದ್ದು ನಾನು ಪ್ರವೀಣ್ KM ಇಲ್ಲಿಂದ ನಿರ್ಗಮಿಸ್ತಾ ಇದ್ದೇನೆ. ನಿಮ್ಮೆಲ್ಲರಿಗೂ ಶುಭಾಶಯಗಳನ್ನು ಕೋರ್ತಾ ನಿಮಗೆ ಉತ್ತಮವಾದ ಯಶಸ್ಸು ಸಿಗಲಿ ಅಂತ ಭಗವಂತನಲ್ಲಿ ಹಾರೈಸ್ತಾ ಧನ್ಯವಾದಗಳು.